welcome to Depth Tested. As we're moving ahead, so if you haven't seen my previous videos, please check that out first. Again, it helps to set the stage for everything that we'll be learning today and for our upcoming lectures. Today, we'll be learning Ferrari's method. Without further ado, let's dive in. So while the previous method handled the cubic degree 3, that is Cardano's method, Ferrari's method is the classic technique for solving the general quartic equations, that is degree 4. For example, let's assume an algebraic equation ax to power of 4 plus bx to power of cube plus cx to power of square plus dx plus e, which is equals to 0. To make it monic, we'll divide the whole equation by a. So we'll have x to power of 4 plus bx cube by a plus cx square by a plus dx by a plus c by a equals to 0. We can replace b, which is equals to b by a, c, which is equals to the capital C, equals to c by a, capital D equals to d by a, and e, which is equals to e by a. We can replace this in the equation. Consider this is equation 2, and these are below the sub-equations. If we substitute them in equation 1, we'll get x to power of 4 plus bx cube plus cx square plus dx plus e, which is equals to 0. So the Ferrari's method tells us to replace x with y minus b by 4a. Let's understand Ferrari's method by solving example. That would be much easier. Consider an equation that is x to power of 4 minus 4x cubed minus 7x squared plus 22x plus 24 equals to 0. As this is already monic, so there is no need of division. But let's make it into a depressed quartic by removing x cubed. So for that, we'll be substituting x with y by b for a. So which is equals to y plus 4 by 4, which is equals to y plus 1. So our x to power of 4 would be y plus 1 to power of 4. That is equals to y4 plus 4y cube plus 6y square plus 4y plus 1. And now come to minus 4x cube. So my minus 4x cube would be minus of 4 y plus 1 whole cube, which is minus 4 y cube plus 3y square plus 3y plus 1. This looks good. And my 7x square is minus 7 into y plus 1 whole square, which is equals to minus 7 y square plus 2y plus 1. And my 22x is equals to 22 y plus 1. And my 24 remains as constant. So if I combine all this and try for elimination so that my reductants can be removed, let's see if I can eliminate any. My 4y cube over here and my 4y cube over here, this one, would be eliminated. So if I combine and write, I would get straight combine. That would be y to power of 4 minus 13y square plus 36. Told you, depressed quartic. And my y squares whole square minus 13y square plus 36. I can represent it's like more simpler. Now I can represent my y square as u. So if I substitute u, it would be u square minus 13u plus 36, which is equals to 0. Can I find u? Yes. That would be 13 plus minus under root 169 minus 144 by 2, which is equals to 13 plus minus 5 by 2, which again is equals to 9 or 4. So let's substitute. So my x equals to y plus 1. So my y equals to 3. So x equals to 4. If my y is minus 3, then my x equals to minus 2. If my y is 2, my x is 3. If my y is minus 2, then my x is minus 1. So I can say for this value, x is minus 2, minus 1, 3, and 4. That's the Ferrari's method. I hope you understood. Have a great day and happy learning.